Hello students, this is an optional awesome lesson on the law of sines. So we've been talking about what is sine. Sine is opposite over hypotenuse. But for this, we're going to do something really different. This is our trig table. I love it. Bye. Okay, what is different about this triangle? And what do you think we're going to try to do with it? What do you see here? I see two angles and a side. What could we solve on this? Could we find this third angle? Sure. And add these two up and take away from 180. We have two angles and a side given. The law of sines lets us find these other two sides. We have an angle and we know its opposite side length. If you are looking at a triangle and trying to find missing sides and missing angles, if it's a right triangle, you're happy. If it's not a right triangle, you have to use a little bit more complicated formula. But if you have an angle measure and you have its opposite side length, you have enough information. Okay, if you have two angles and an opposite side, then you have enough information. So let's look at how we do this. This is called the law of sines. It's a formula. And if you practice it and use it, you'll get better at it. If you just watch me do a bunch of problems, you won't get better at it, but it might be interesting. And it says that there is a relationship here. There is a strong relationship between the size of this angle and how big this side length is. And you can see that the angle gets bigger, the side length is going to get longer. The angle gets smaller, the side length is going to get shorter. Okay, so there's a strong correlation here, or relationship between how big this angle is and how big this opposite length of this side is. The same thing is true for the other ones. So if angle B is over here, and I know maybe it's a different size angle, but I know that if I change that angle, it's going to change the length of that opposite side. So this angle is related to this opposite side. Okay, same thing here. If I know the size of angle C, it's going to give me information about the length of the side opposite. This is the law of sines. It's a double proportion. It has a proportion and another proportion. It's actually a really easy formula to memorize because it's just sine of A over A, sine of B over B, sine of C over C. The capital letters are for the angle names and the lowercase letters are for the side lengths. So let's try it. Let's try to use the law of sines to find YZ. YZ is here. I'm going to call this C. I'm going to change the name of this angle to C because it's going to be a heck of a lot easier to use the formula. Okay, I'm going to change this angle to A. And I'm going to change this side length to A. And just since we're on a roll, I'm going to change this name of this angle to B, and this side is B. All right, if I'm learning a new formula, I want to try to keep it easy for myself. So I'm going to set up the proportion. The formula says that the sine of A goes with the side length A. The sine of B goes with the side length B. And the sine of C goes with the side length C. That's the relationship. And I'm going to use some of that in order to solve for YZ. I'm trying to find, in this problem, I'm trying to find out what that is. It's annoying me. I'm going to put a question mark right here. Okay, so here's how I set it up. I know that the capital letter represents an angle measure. So instead of using A, what am I going to use? I'm going to use 77. So the sine of a 77-degree angle goes with, what's the side length for A? How long is A? It's 7. It's nice. Okay, do I know the size of angle B? I kind of do. Okay, we talked about that. I could find that, but for right now, I'll leave it alone because we don't really have a lot of information between this relationship. But we do know the sine of a 51-degree angle goes with whatever the heck I'm looking for. Okay, and when you're using these problems, you actually only need 2 out of the 3 because we can solve proportions. So I'm gonna just not worry about this for now. And I'm gonna put these next to each other, and then I'm gonna solve this math problem. This is called a proportion. Okay, this is the sine of 51 over some number that I'm trying to find out. Okay, how do we solve proportions? A really clean way to do it is something called cross products. Okay, or you can use other algebra skills of multiplying both sides by 7, dividing both sides by 51. That would also work. I'm going to use cross products, so I'm going to do C times the sine of 77. That's just a weird decimal. You don't have to worry about it. And then I'm going to do 7 times the sine of 51. Okay, we're trying to find C, so we're going to divide both sides by this, the sine of 77 and the sine of 77, divide both sides by the same thing. It looks messy, but it's not hard. Okay, and then the nice thing about calculators is you can type all that into the calculator and it will tell you the answer. So let's go do that. Let's do 7 times the sine of 51 divided by the sine of 77. 7 times the sine of 51, all of that divided by, oh boy, that's not what I want. I want all of that divided by the sine of 77. Boom, answer, 5.58. Maybe I'll round that to 5.58. So how long is side C? 5.58. Is it reasonable? How can I tell if it's reasonable? Well, this angle is bigger than this angle. So this side has to be smaller than 7. Is it? Yeah. Okay, so 7 has a bigger angle across from it, and 51 has smaller, so this side has to be smaller. That's the answer. We did it. Okay, this is an approximate answer. Sorry. This should be a squiggly equal sign. Approximate. All right, let's do it again. So use the law of sines to find xz. So now I want to find this side. We called this B. I'm just going to put this back, except I'm not going to change colors this time. We were using this as A. This was A. This was angle C, and this was the side length C. If you set that up, it's going to save you a lot of headache when you're substituting into the law of sines formula. We can use the law of sines because we have this relationship already. We have the angle with the side length. That's a good thing. So the sine of A over A, it's a really easy formula to memorize. Sine of B, angle B over side length, and the sine of C over C. Yay! Okay, but I already had the sine of 77 over 7. But this is the part that we ignored last time, right? Because we didn't know the measure of angle B. So now let's actually do it. So we have 51 and 77. That is 7, 8, 9, 10, 11, 12, 128 plus something plus measure of angle B. It's going to get us to 180. So I know this is a little extra, but 180 minus 128. I'm going to do that on my phone calculator because just easier. Okay, 52. The measure of angle B is 52 degrees. If you don't believe me, you can multiply, or you can add 52 and 51 and 77, and then you should get 180. What's the shortest side on this triangle? C. What's the longest side on this triangle? A. How did I know that? Because I'm smart. All right, we're trying to find B for this problem. This is like what we're solving for. And I now know that the sine of 52 degrees. Okay, this time I don't need this information. Okay, I'm going to use these two ratios to set up this proportion. And I'm going to do the same thing I did before. Sine of 77 times B. I'm using cross products. And I'm going to do 7 times the sine of 52. And I'm trying to figure out what B is. So I'm going to take this side and divide by the sine of 77. It looks messy, but you guys, these are just decimals, right? And you can, now that you're in higher math, you can do calculator work, right? So this is the sine of 77. This goes to 1. And if I plug this into the calculator, it will give me the answer. Now, is the answer going to be more than 7 or less than 7? Going to be less than 7. Let's go see what this is. We're going to do 7 times the sine of 52 divided by the sine of 77. Oh my gosh, that's already in there. So I just have to change this to 52. So smart. 5.67 or 5.66. Okay, that makes sense. Okay, this was 5.66. How much was the other one? This one was 5.58. 5.58. Okay, and so yeah, we're getting there. This is the shortest side because it's across from the shortest angle. This is the longest side because it's across from, these two are really close together, but this angle is a little bigger, so this opposite side is a little bit longer. Okay, use the law of sines to find x and y. Same idea here. Here is our key right here. This and this. Okay, we have a side length and we have its opposite angle measure. So we're all good. And you know what? I might as well right now do 81 and 31. Okay, and then subtract from 180, I get 68. We want to try to solve everything. And we had 2 angles and one side length, and that's going to be enough to solve this triangle. Pretty amazing. Okay, we know we have enough information. If we have the angles and we have one side length, we have enough information to find the other 2, even if it's not a right triangle. We can use the law of sines. So this time I'll set it up. Sine of A over A equals sine of B over B equals sine of C over C. And I'm going to do it all on the same work now. So this is the sine of an 81-degree angle over 18. This is my key, right? I have both. That's a good thing. And then I'm going to do the sine of, which one do you want to be? B. Let's call this one B. Sine of a 31-degree angle over X. And then we have the sine of a, we're going to call this C, 68-degree angle over Y. All right, let's solve for X first, and then we'll solve for Y. So I'm going to set up the proportion over here. This is going to be sine of 31 over X. And then I'll actually set the other one up too. I'm going to do the same idea. Sine of 81 over 18 equals the sine of 68 over Y. Okay, those are my 2 problems. This one I can solve for X, this one I can solve for Y, and then I'm done. So I'm going to do this. Okay, I'm doing cross products. 18 times the sine of 31. I divide both sides by the sine of 81 degrees. And X is going to be whatever that is. Okay, so I'll type it in, 18 sine 31 over sine 81. 18 times the sine of a 31-degree angle divided by the sine of an 81-degree angle. 9.39, I'll round it to 9.39. Hey, is it reasonable? Is that the shortest side? Yeah, that looks pretty good. All right, let's solve this one. Sine of 81, I'm going to multiply that by its cross product, and we have 18 times the sine of a 68-degree angle. Divide both sides by the sine of an 81-degree angle. And that's going to give me my approximate answer. 18 sine 68 over sine 81. 18 sine 68. Notice, like, if you use this, it's already in there. You can just change the numbers. Okay, so this is 16.89, or I could round that up to 16.9. Is that reasonable? Is this the shortest side? 9.4. Yes. Is this the next shortest side? So smallest angle, smallest side. Next biggest angle, next biggest side, 16.9. Does this look reasonable? Yep. And 18, longest side, biggest angle. Good. Got it. Woohoo. All right, this one, same idea. Okay, so let's see if we can do it a little faster. I'm going to move it. You see what I have here? I have two angles. I actually have the third angle, and I have a side. And I have the relationship between an angle and its opposite side. As long as you have this, using law of sines is really good. All right, let's find this missing angle first. So we get, I'm doing 180 minus 87, and then I'm going to minus 41. I get 52 degrees. All right, I'm going to set it up. Sine, I always write the formula, even though I've done this so many times. I always write the formula. Sine of B over B, sine of C over C. Okay, and then I'm going to plug and chug. So I have the sine of a 41-degree angle goes with 10. Okay, and then I have the sine of a, let's do B next. Oops. Oh, I wanted to make this 87. 87-degree angle goes with X. And I have the sine of a 52-degree angle goes with Y. This is the same thing I just did on the other slide. Okay, I'm tired. You guys can do that. If you're not sure, rewind the video and watch how I did it. You guys can try this one for yourself. Make sure that 10 is your smallest answer and that this one's bigger and that this one's is the biggest. If you get that right, good job. All right, this one is different, but also possible. So what's different about this triangle? We have two sides and one angle. Can I find these angles? Can I solve this triangle? I can. Okay, it's a little different. The thing that you should notice is we have the angle and we have its opposite side. So we can use the law of sines in order to do this problem. So if I want to solve the triangle, I'm going to go for this angle. Okay. I could do a lot of work on this. Let's just, for now, let's just find this missing angle. So this is a little different process, but it's very similar. So I'm going to rename this A because it's annoying. And I'm going to rename this B because I feel like it. And this will be C. And so for right now, I'm not going to solve the triangle. I'm just going to solve for the measure of angle B or N or whatever we want to call it. Okay, so I'm going to set it up. The sine of A over A equals the sine of B over B. This is called the law of sines. It says that the angle size has a strong relationship to the length of that side. The angle gets bigger, the length of the side, the angle gets smaller, the length of the side there's this really strong relationship there. So I'm going to do the sine of a 70-degree angle is 4. I'm not going to include units right now. Okay, and then I'm going to do the sine of B is 2. And I'm not going to worry about this for right now. All right, this one's different because we don't have the angle measure. So let me show you how to do that. I'm still going to use cross products. Okay. Okay, and I'm going to divide both sides by 4 because I'm going to get my unknown kind of by itself. So I need to find out what the sine of B is. Okay, so I'm going to, how am I going to do this? I'm going to go figure out what this is as a decimal. So I'm going to go type this into a calculator. Okay, 2 times the sine of 70 divided by 4. Well, that's actually half the sine size of sine. 2 times the sine of 70. Did I say 70? Yeah, 2 times the sine of 70 divided by 4. Okay, so I get this decimal. So 0.4698. I'll take all 4 of those. 0.4698. There's a few ways to do this. The way that I like to do it is on the table. So I'm going to go back to my table slide and I'm going to look for this number in the sine row. 0.4698, 0.4698, 0.4698, 0.46. So I'm looking in the sine row. 0.4695. That's pretty freaking close. Okay. So what angle size has a sine of 0.4695? This angle. So if you can find it here, you can work the table backwards and find the angle measure. So I'm going to say this is about, 28 degrees. Won't do that last one. So that means the measure of the measure of angle B is about 28 degrees. Now, is there a button on the calculator you can push to do that? Sure. So if you want to work the sine function backward, if we know the angle, we can find the sine ratio. If we know the sine ratio, we can do the inverse operation and we can find the angle measure. So let's see if we can find the button on the calculator. Let's clear all that. Okay, and we're gonna have to go find it. So let's look for our functions. Aha, here's the sine, here's the inverse sine. And the notation is kind of interesting. It says sine, the way we read this is the inverse sine. It has nothing to do with an exponent of -1. It's just the inverse sine. So I'm going to put inverse sine, and then I'm going to put in this decimal, 0.4698. Oops, go back to main. 0.4698. Yeah, I was right, 28 degrees. I did that on the table. Okay, or if you want to be really fancy, you don't want to show any work, what you could do is you could do the inverse sine of all of this. And that's going to equal the inverse sine of the sine of B. Okay, if you do the inverse sine, that's going to give you the measure of angle B. So when you do the inverse sine on both sides, this inverse sine and this sine, they're inverse operations, so they go away. And what you're left with is the measure of angle B. And I'm just going to show you how I might do this to get the most exact answer. Okay, I know, sorry, that's a little confusing. I went backwards. We already know that's 0.4698. But if I was going to do it on a calculator, I might do it this way. I might do 2 times the sine of 70 divided by, divided by 4. Okay, that's going to give me the most exact answer because I'm not rounding anything until the very end. Okay, and that still gave me just about the same answer as the table. So that is how you find the measure of angle B. that's 28. About, I could find what this is by subtracting from 180. And then I could go through and I could finish the rest of this. Right, that's your law of sines. It's pretty fun, not too hard, but yeah, you would need to practice it to get good at it. Be good, keep learning, work hard. Bye.